There aren't a lot of people on the planet who do what we do. Most coral biologists like to put on scuba gear, and they want to be in the field, and they want to be studying corals themselves. And corals don't give themselves to cell biology. They don't give themselves to these molecular tools that we can develop. And so we have a niche. Our group, we're a sort of a foundational lab. We study the basic research that underpins a lot of the more applied and solutions-based, so conservation, restoration work that's done in the field. We don't use corals because corals are extremely difficult to study in the laboratory, but we have a little sea anemone that is perfectly happy without its algae. So when we talk about the corals, we have the host and the algae, right? So these algae, they're essentially the equivalent of a giant bowling ball that lives inside your cell. And that is not like, that's an infection, right? And so how does this animal tolerate the infection of millions of single-celled things in your body? One of the most exciting things that my group collectively over the years has contributed to is the understanding that the host, anemone and coral, they're essentially in an immune suppressed state where they tolerate the presence of these symbionts. And that coral bleaching is essentially the invisibility cloak coming off of those algae. So it's the algae are cloaked in the host. And we don't understand how exactly, but there is a tolerant signal that's sent. And they're cloaked, and maybe it's as simple as feeding, like, don't worry about me, I'm giving you sugar, all is well. But the minute that sugar stops, the host is like, wait a minute, cloak comes off, get this thing out of me. And then this big, immune response happens, and that's really what's causing bleaching. So things that we publish in the Weis lab, then often the coral people go, oh, that's really interesting. It's about the anemone immune system. Well, let's go find those genes in corals, and then we're going to try to see if that phenomenon occurs in corals, and then ultimately maybe there will be a way to work with that in the future. So for example, in the Pacific Ocean, there has been adaptation of a single group of algae, and they're super productive and they're wimpy. So they can't handle heat, and they populate almost all the corals there. So all those corals are susceptible. But in the background, there is a species of algae that's not very productive, but tough. The genus name of it is Durastinium durable. So when all of the wimpy ones die, Durastinium moves in and populates the host, which can be good, but they're not productive. So if we could make the wimpy strains and perhaps engineer them with some of the durable traits that the durable algae have, or vice versa, if we can take the durable algae and make them more productive, we might be able to engineer our way, assist corals in evolving to be more tolerant. But you can't do that if you don't know what to change. And so what my group does is we discover how the symbiosis works, how do they make decisions about which partner is the right partner for them, how do they maintain their relationship, and then importantly and sadly, of course, what happens when that partnership collapses as a result of climate change-induced global warming. Once you have that basic information discovered, then you can use that as fodder for your solutions. And so that's what we do.